A strange comet-like body is drawing the attention of scientists across the world. Some argue it may not be a comet at all, but something far more unusual. One leading astrophysicist, Professor Avi Loeb, has suggested it could even be a fragment of alien technology. What's clear is this: the object isn't behaving like anything we've ever tracked before. It moves too fast to be bound by the sun's gravity, following a trajectory that defies expectation. It arrived suddenly, out of the dark between stars, an interstellar wanderer older than Earth itself, now racing past our sun at mind-bending speeds. Its chemistry doesn't match the familiar recipe of comets within our solar system. Instead, it seems to carry something entirely foreign, releasing gases that suggest both volcanic origins and possible links to life. Stranger still, the signals recorded as it passed did not line up with standard models. To many, the question became unavoidable: what exactly is this thing, and why does it behave as though it is alive? The story began quietly on the night of July 1, 2025. Atop a peak in northern Chile, the Atlas telescope registered a sudden streak across the starfield, fast, bright, and clearly from beyond our solar system. Within hours, astronomers confirmed it wasn't orbiting the Sun but cutting straight through on a hyperbolic path. The designation came quickly: 3I, Atlas, the third interstellar object ever discovered, after Oumuamua in 2017 and Comet Borisov in 2019. But unlike its predecessors, this visitor was brighter, more active, and offered scientists more time to observe it closely. Its speed was staggering, over 130,000 miles per hour, fast enough to travel from Earth to the Moon in just about an hour. Orbital calculations showed it likely originated not from nearby stars, but from the Milky Way's ancient thick disk, a region that predates the Sun and Earth by billions of years. That made 3I, Atlas not just rare, but possibly one of the oldest frozen remnants ever to enter our system, a time capsule from the galaxy's earliest days. When telescopes zoomed in, the mysteries deepened. Instead of releasing water vapor like a normal comet, Atlas spewed record amounts of carbon dioxide, with traces of carbon monoxide, hydrogen cyanide, nickel, and carbonyl sulfide. The ratio of carbon dioxide to water was so extreme that it broke all expectations. Some astronomers suggested it must have formed in a very different kind of star system, far colder than ours, where carbon dioxide ice was abundant. Others speculated that it might represent a class of objects we've never seen before, frozen relics from environments where Earth-like planets may never have existed. Images taken by observatories around the world revealed a glowing coma unlike any seen before, shimmering with ionized gases and unusual light patterns. Even more bizarre, the comet produced an anti-sunward jet, as though material was being expelled toward the Sun rather than away from it. This raised questions about whether its volatile chemistry was driving unexpected forces, or whether something else was at play. As it curved past Mars and later crossed Venus's orbit, international teams coordinated continuous observations. From ground-based telescopes to the James Webb Space Telescope, they measured every flicker of light and every spectral fingerprint. Its rotational period, dust composition, and organic-rich tail suggested it was carrying molecules that could be billions of years old, older than the Earth itself. The sheer strangeness of the data ignited speculation. Was this simply a natural comet, born in a distant system under alien conditions? Or could it be something more, a relic probe, a discarded fragment of technology, evidence that civilizations might once have seeded the stars with messengers? While most astronomers argued for a natural explanation, voices like Avi Loeb's reminded the public that we should not dismiss extraordinary possibilities too quickly. Importantly, 3I, Atlas posed no threat to Earth. Its closest approach was nearly 270 million kilometers away, 7 times the distance to the Moon. Even though bursts of gas and dust pushed against its surface and slightly altered its path, its hyperbolic orbit meant it was never going to stay. The sun could not capture it. Like a cosmic visitor with no intention of stopping, it entered our neighborhood, revealed its mysteries, and then continued on its way. Yet, even in its passing, the object stirred something profound. Scientists and the public alike were struck by the sheer improbability of it. This was only the third interstellar body ever confirmed, and already it behaved in ways no model had predicted. It wasn't just an astronomical curiosity, it was a puzzle that invited us to rethink the boundaries of what we know. For researchers, Atlas was a priceless opportunity. Its chemistry was a direct clue to environments far beyond our solar system. The extraordinary levels of carbon dioxide, the imbalance between gases, and the unusual spectral fingerprints did not fit the patterns of familiar comets. That meant it was forged under conditions alien to our Sun, perhaps near a colder, dimmer star, or even in the turbulent remnants of a dying system. Each molecule released from its icy shell carried a story billions of years old, a story from somewhere we may never reach. This forced scientists to revisit long-held ideas about how comets form, how planetary systems evolve, and how material drifts through the galaxy. Atlas reminded us that the Milky Way is not a uniform place. Worlds may form under wildly different conditions, and the debris they cast into interstellar space can carry those fingerprints with them, frozen for eternity. Beyond pure science, Atlas sparked imagination. If this is only the third interstellar object we have found in such a short span of years, how many others slip past unseen? Could they carry building blocks of life between star systems, scattering chemistry that may one day spark biology on new worlds? Some scientists point to the possibility of panspermia, the idea that comets and asteroids might transport life's ingredients across the galaxy. To them, Atlas wasn't just a rock, it was a messenger of possibility, proof that the cosmos shares its raw materials freely. Others went further. They wondered whether some interstellar visitors might not be entirely natural at all. The unusual trajectory of Oumuamua years earlier had already opened that door in public imagination. Atlas, too, carried features so strange that whispers of technology and design inevitably arose. While most astronomers held fast to natural explanations, the question lingered. What if some of these messengers were not shaped by chance, but by intention? By the time Atlas faded from view in late 2025, its legacy was already secured. In just a few months, it reshaped the way humanity thinks about the void between the stars. It proved that our solar system is not an isolated island but a crossroad, a place where travelers from across the galaxy occasionally pass through, unnoticed until we happen to catch them. And with each detection, the probability grows that the universe is teeming with these silent voyagers, carrying knowledge, chemistry, and history across unimaginable distances. Atlas did not send a radio signal. It did not decelerate or shift direction or reveal secrets of technology. It remained silent, cold, and alien. But even in silence, it spoke volumes. It reminded us that the cosmos is alive with motion, filled with ancient travelers older than Earth, and that the unknown drifts closer than we ever imagined. For humanity, it was both a wake-up call and a promise. The next visitor might arrive in 10 years or in 100. And when it does, we may be ready, not just to observe from afar, but to meet it with spacecraft, instruments, and perhaps even robotic hands to touch what no one has touched before. Atlas was not a threat. It was a teacher, a messenger from deep time. And in its fleeting passage, it left humanity with awe, curiosity, and questions that may take centuries to answer.